So you've got your paper. Yes? Okay, so you have a choice here at the beginning. Okay, one that I don't care. The first step is, do you see the edge all the way around? It's so close to the edge that you can cut it or not cut it. I don't care which one you do. I'm going to cut it just because it's there and I don't want the border. But if you want to leave it, you may. Okay, you got it? Almost? Once you cut all the way around the outside, now we need to fold. Okay? First fold I'm going to make is on this line and this one. Everybody see why it's called a foldable? Oh, okay, good. Okay. Then I'm going to fold this to the very next line, because when I make this fold over here, that's on that line, right? And fold back and forth and back and forth so you get it all the way folded. Yes?
You're Connor Mackey.
I do?
Send him to the office.
We're right in the middle of notes. Can he come in a moment?
Yes.
Thank you. Everybody okay? So does yours look like this? Almost? Okay. Okay, so do you notice how these lines right here are dotted, but this one's not? And how these lines right here are dotted, but this one's not? That's on purpose. Okay? What I'm going to do is I'm going to grab this much all together, but not the part that says graph. Okay? Because what I'm going to do is I'm going to cut where it's dotted. And then I'm going to cut where it's dotted. I don't have the word that says graph in my hand. It's still sticking out. So that it looks like this when you get done cutting. Everybody okay? Sir.
I'm supposed to be leaving.
Oh, leaving?
I have like 1 minute.
Yeah, go. Sorry. She didn't say leaving.
It always.
You're fine. If you're supposed to leave, go. Okay, is everybody good here? Alright, so I'm going to zoom in so you can see what I'm writing. Zoom in. We're going to start on standard form. Okay? So today we're going to start our unit on quadratics. Okay, what is quadratics? Remember? What's the equation look like if it's quadratic? X squared. Right? X squared is quadratic. Y equals x squared is the parent function of quadratic. Remember talking about that in August? I know it's been a while. Okay? Y equals x squared is a quadratic. Okay? But there's three forms to start with that we're going to talk about. Now I need to make it clear also here at the beginning of this chapter, we are only talking about functional parabolas. Only parabolas that are a function. What do I mean by parabolas that are a function? What test do they have to pass to be a function? The vertical line test, right? So that means the parabola is either going to open up or down, right? It's not going to open sideways because sideways wouldn't pass that vertical line test, right? So only parabolas that open up or down. Are there parabolas that open left and right? Are there parabolas that open diagonal? Yes, right? We're not ready to talk about any of those. We're only ready to talk about parabolas that open up or down. Okay? So we're going to start with standard form. So, were you all judging me because it's not centered on the little rectangle? Yes, of course you were. I'm just teasing. I did it this way on purpose because we're about to write what standard form is right in this space. Okay? Standard form of a parabola is y equals ax squared. Could you finish it for me? Plus bx plus c. Absolutely. Okay. All right, you got that part? Now we're going to open it like this. And all the stuff that we write in this little section is going to be about standard form. Okay? The axis of symmetry for standard form is x equals negative b over 2a. Pretty straightforward, right? Look at the equation, find b, find a, plug it into this little formula. X equals negative b over 2a. Remember though, when we actually write our axis of symmetry, we have to write x equals 2, x equals negative 1, whatever it is, because the axis of symmetry is also, another word for axis of symmetry is line of symmetry, and we can't call a line just by a number, right? We have to call it by its equation. Okay? Now, look at the vertex. Would it make sense to you that the x-coordinate of the vertex is negative b over 2a? Where does the axis of symmetry go on a parabola? Right through the vertex, right? So does it make sense if the axis of symmetry is x equals negative b over 2a that the x-coordinate of the vertex would be negative b over 2a? Okay, good. Now, the y-coordinate of the vertex looks messy. Don't let it scare you. Okay? It looks messy. It looks like this. F of negative b over 2a. Well, all that means is to take the x value, substitute it into the equation, to find the y value. Oops. If this said f of 5, you would know to take the 5 and plug it in, right? If it said f of negative 1, you would know to take the negative 1 and plug it into the equation, substitute it into the equation, right? It's just messy because we don't know what b and a are yet. As soon as we do, we'll have a number, and we put that number into the equation to find the y value. Does that make sense? So miscellaneous is going to be other things that we know about the parabola based on what equation that we're using. Okay? When we have, I'm going to close this up just a second so you can see it. When we have standard form, something really easy for us to see is the y-intercept. Okay? And the y-intercept is 0, c. How easy is it to see what the y-intercept is? Yeah, you look, it's right there. Whatever number that is, that's the y-intercept, 0, that number, 0c. Okay? So let's draw a graph. Now this is not a real specific graph, this is a general graph. Okay, just a real general graph. Well, how about if it looks something like that? Make it like parabola-ish, right? So the things that we can know by standard form is the vertex. We can know the axis of symmetry. And what else can we know? The y-intercept. And where's that? Yeah, it's where it crosses the y-axis, right? That's at 0c, and that's the y-intercept right there. Does that make sense? Any questions about that? Any questions at all about standard form? You good with all this for right now? Okay, we're going to close that up. And now we're just going to look at vertex form. Vertex form is y equals a times x minus h squared plus k. Okay, this is vertex form. Now when I open it up this time we're going to do the vertex first. Does it seem logical to you that the vertex would be really easy to find if the form is called a vertex form? Yes? Okay. The vertex is at h, k. See how easy it would be to find the vertex if it's in vertex form? Okay. So knowing what you know, knowing what we discussed about standard form, can you tell me the axis of symmetry in vertex form? How do those two compare? And then tell me the axis of symmetry for vertex form. X equals what? Yeah, h. See how those two are the same? See how those two are the same? Does that make sense? Now, we need a star here. What does that mean? Do you know? Yeah, it's Spanish. What does it mean? Be careful. Caution. Cuidado. Okay? We have to be careful because we have to be careful of the signs. What is in the formula? X minus h. So if this said x minus 2, what's h? It's just 2. It's not negative 2, even though it looks like negative 2 if it says x minus 2, right? But it's just 2 because the minus is in the formula. Okay? So if this said x plus 3, then what's h? Negative 3. Exactly. Does that make sense? So let's go ahead and remind ourselves that it's opposite of the parentheses. And just to make sure, we're going to go ahead and put a star over here too. I don't need to keep writing that. I don't need to write cuidado again, do I? Because you know what it means right here, right? Okay. Let's go look at the graph. in vertex form. Is it all right with you if I make this one open down? No reason. I just want to make sure we're talking about ones that open up or down. We already did one up here that opened up, so now we're doing one that opens down. Okay? So what can we know based on vertex form? Vertex for sure. What about the line of symmetry? There's nothing else though, is there? Not that we can tell right away just by looking, not like y-intercept like we could on the previous one, right? Yeah, there's nothing really for miscellaneous for vertex form, so you can draw a penguin or not, that's fine. Okay. Ready for vertex form to be closed up? Do you have any questions about vertex form? Okay. And let's go to intercept form. Close those up. Move it to intercept form. Whoop. Intercept form looks like y equals a times x minus p times x minus q. Now at first, does this look like a quadratic? What did I say quadratics had to have? X squared, right? This doesn't have an x squared anywhere, but what are these two things doing to each other? Multiplying. And if I distribute this, what do I get? X squared, right? So it is a quadratic, right? Okay. So I'm going to open it up. Why is it called the intercept form? Close. It is intercepts, but it is the x-intercepts. Okay? So picture a parabola in your head real quick. Close your eyes if you need to, but picture a parabola in your head real quick. Or look at the ones we've already drawn. Okay? Where is the vertex in relationship to the x-intercepts? Right in the middle? So would it make sense to you then the axis of symmetry? We have to say P plus Q divided by 2. Because isn't that finding the average of the two values? If we add them together and divide by 2? Yeah? But I need to start here. Why? Because why? Isn't that the same thing? Isn't the minus part of the formula? So again, it is correct of parentheses. What's the x-coordinate of the vertex? Can you tell me that? So just P plus Q over 2 again? Is that the same for all of these? Is the axis of symmetry the x-coordinate of the vertex? Yes. So P plus Q over 2. The y-coordinate is messy like it was in the previous one in the standard form. It's f of P plus Q over 2. But once you know what P plus Q over 2 is, it's not messy anymore, is it? Because what are we doing with that? You're taking the x value, substitute it into the equation, to find the y value. Now I'm going to put a star on this one too, for the same reason that I have a star over here, right? Because we have to be careful of the signs. What do you think we have in miscellaneous this time? X-intercepts, absolutely. Where are the x-intercepts? P what? Good guess. P what? 0. Very good. And where's the other one? Q0. Very good. And I'm going to go ahead and put a star here as well, right? Because I still have to be careful of the signs. You want this one opening up or down? Right, it doesn't matter. You want it opening up? Okay. How about if we make it like this? Like really thin. Is that okay? What can we know by the by the intercept form? For sure I know vertex. For sure I know axis of symmetry or line of symmetry, right? And what else do I know? Yep, x-intercepts. That's an x-intercept. That's an x-intercept. Now, what am I going to do if you try to use this on a test? Yeah, I'm going to throw it in the trash. Why? No name, right? For the record, I wouldn't really throw it in the trash. Okay. Again, you're not writing my name, you're writing your own name. Okay? Now is it acceptable to use this on a quiz or a test? Yes. And homework? Yes? Any questions about the beginning, the very first day of quadratics? You good?